And I believe we should be live. If anyone's already watching, say hello in the chat. See a few people here already. We'll get going here in just a minute. While we're waiting for some more people to join in, if you want to share in the chat where you're watching from, it's always kind of fun to see, where everyone's tuning in from. I'm streaming from Seattle. And while people are still joining in, I'm also going to share a couple links for if people want to follow along. So we'll go through just a little bit of slides to catch everyone up, and then we'll go mostly be doing a kind of a more hands-on code portion today and using the ylogs platform to view our data. So if you want to follow along with everything we're going to do today, you can go ahead and sign up for the ylogs account if you don't already have one. It's free. There's no credit card or anything required. And then this is going to be the Colab notebook that we'll be using today. So if you want to save that link, you can always come back to it as well if you're not going to run all the code right now. And then we're going to be using our open source library called ylogs to profile our data. And then we also have a Slack group. If you want to join this and ask any questions after the workshop, that's a good place to do it. And then I'm going to share these links one more time on our LinkedIn stream, and then we'll get going. But again, if anyone wants to say hello in the chat, maybe where you're watching from, how are you doing today, what you're building with machine learning, it's always kind of interesting to hear a little bit more about the audience. And if you open up that GitHub link and you want to give us a star, always appreciate it as well. Somebody said hello. Hello, awesome. Thank you for tuning in. All right, so we're going to get going here in, 30 more seconds or something like that. Again, we'll just be going through a few slides, or more than a few, but then we're gonna go into the Colab notebook and kind of see how we can segment our data and kind of monitor it for bias or fairness with a feature we call tracing. All right, now I shared the, oops. Somehow I skipped a whole bunch of slides. Shared the links. Right, so I'm gonna go ahead and get going on the slides, and some people might tune in, but we'll have a little bit of time before we get to the hands-on part anyway. What this workshop is, so hopefully it's a super friendly introduction to ML monitoring for bias. So kind of no previous experiences expected, but we will be using Python, and knowing some machine learning concepts would be helpful. We're going to recap some of the high-level concepts around kind of ML monitoring and bias, and then we're going to go jump into that Colab notebook that I shared and kind of run code and look at the data ourselves. So hopefully you want to follow along. Depending on your level of knowledge and stuff, this could be a little fast-paced. It's kind of like a crash course in this stuff. So if it feels fast-paced or challenging to you, that's totally okay. Just keep learning. And what was I going to say? Oh, so if you came in from a previous workshop, so a couple weeks ago, we did one that was Intro to ML Monitoring. And this is kind of a sequel to that workshop. A lot of people were asking about like monitoring for bias and stuff, and that's what we're going to be looking in today. It's okay if you didn't attend the other one, but we won't be going as deep into some of the topics that we dive deeper into in the last workshop. But I'll still share all the code and stuff actually to that is in that same notebook we're going to be using. There's just kind of 3 parts to it. Quick introduction about myself. I'm Sage Elliott. I'm a machine learning and MLOps evangelist at ylogs. At ylogs, we're building tools and tools around AI observability and ML monitoring. So we have open source projects, and a platform. We'll be seeing both of those in action today. For about the last decade, I've worked as a software engineer or hardware engineer with mostly startups and agencies in Seattle, but also a couple places in Central Florida. And it's actually kind of funny. I was thinking about this the other day. My first kind of career really was doing hardware reliability engineering. And now I kind of work with AI reliability in a way. So it's kind of fun to go from, or think about how I went from hardware now over to AI, and still using kind of not the same tools, but thinking, kind of in similar ways about how to make these things more reliable. About you. So if you're in the audience, if you want to throw in the chat, where are you watching from? Why are you interested in ML monitoring? That'd be fun to hear. And then again, if you want to stay connected in the Slack channel, you can do so here. And I won't see questions if you post them in there right now. So keep posting questions in the live chat and I'll see those. So you, feel free to ask questions as we go. And again, setup for anyone who just tuned in. These links are also in the description. I don't know why my slides feel like they're going wild today. All these links are also in the description. So if you tune in at any point or you come back to the recording, which is going to be at the same YouTube or LinkedIn link, you can go ahead and go to the description and open up these links and follow along later as well. So again, the only thing you'll probably need to do if you don't already have one is just the free YLabs account. If you came from a previous workshop, you probably already have an account. Otherwise, you just need a Google account because we're going to save a copy of something called Google Colab, and we're going to run the code there. It's kind of a neat code environment that we're going to use. And then we're going to use scikit-learn to train a model and run predictions on that model. And then we're going to use our open source library called ylogs for creating something called data profiles of that data set. And then we're going to use the YLabs platform to kind of investigate our data in this case and maybe see how it's performing on specific segments, potentially for bias. Again, ML monitoring at a high level. We talked more about this in the last workshop, but just to kind of recap here, you have some sort of data and ML pipeline, your whole infrastructure set up here. Out of that ML pipeline, you're probably collecting, or if you want to do monitoring, you should be collecting some sort of AI telemetry. So that can be things around data quality, distribution, summary statistics, data lifecycle events. And then often you're going to be storing that telemetry in some sort of platform or some sort of way where you can view it and do something with that data. So that could be like aggregate those statistics, do a forecast, detect. The last workshop, we talked a lot about detecting things like data drift and monitoring for those. So you could automatically get an alert or notification or trigger some sort of workflow event in your MLOps pipeline. Or you might want to just kind of keep an eye on that data and get reports and look at the dashboard. And to recap how we work, we have our open source library called ylogs. You can see a little example here where we can really profile data of any kind, including images, tabular data, and then we have an open source library also called langkit that's built on top of it, that's built around specifically for monitoring LLMs. And then you can send that data to YLabs, which is our observatory platform. And then in that platform, you can easily set up all those things. And so we covered detecting data drift and setting up a monitor and looking at some performance metrics in the last workshop. And in this one, we're going to go kind of the step further where we're going to look at some of those same things, but instead of having a clear thing around like data drift on all of our data, we're just going to have, spoiler alert, some bias going on with a specific category. And so this will tie together or show how to look at data for bias and fairness kind of in probably most of your situations that you might encounter. So quick recap on what is ML monitoring. Again, we looked at previously looking at model inputs for like data drift, data quality, and data schema issues, which I think are like the pretty common things that people encounter when you put a model in production. But you also have things like on the model output, the volume coming out, the concept drift. And then today we're going to specifically really look at more of bias and fairness, which is why it's in bold here. But just to recap kind of on data drift is often where the inputs going into your model no longer really matches the distribution of your training data set, is one way it can drift. And chances are, if it doesn't look like the data that your model is trained on, it probably isn't going to be performing as well. So it's good to catch those things kind of early on and verify that either your model is performing well, or maybe even taking that new data and then retraining your model to make it a little bit more robust in production. We have a saying, bad data happens to good models. Has anyone experienced any of these problems in the past, like data drift or data quality or schema change that kind of broke your whole ML pipeline? Again, let us know in the chat. And just to kind of recap again, what monitoring an ML application might look like is you have your pipeline. You can really put in monitoring anywhere in your pipeline. Some people that have large pipelines and even use ylogs or ylabs, not even for ML, just for data, they might put it at multiple points. So they want to log what's going on at different areas and stages of their pipeline. But if you're just getting started, I always recommend just monitoring the input data directly going into your model and the output coming out of your model. And then, if possible, sometimes get some ground truth data just to double check those like accuracy metrics. But if you can't do that, because that can sometimes be costly with more data annotation or your time going in, you can actually usually gain a lot just by looking at the input and then the direct outputs over time. So bias and fairness in ML. I'm sure people here have heard some of these stories over the past several years where, there's been problems with, credit scoring, facial recognition, criminal sentencing, medical diagnostic, hiring, voice recognition. If you're looking at products or making predictions in different regions and your model was trained on a specific region of the country or specific countries, or product categories, like you're trying to make a prediction on, where a category belongs or how many people are going to buy, and your model is just not trained very well in that category, and it's going to be messing up those predictions. Does anyone have a AI bias and fairness story they want to share? Even if you've experienced it, even like you try to do a generative AI model and you use it on your face and it changed the color of your skin or something like that. So a lot of the time this comes from the data set being biased. Sometimes it might be algorithm design as well, but I'd say most of the time probably you're training some sort of machine learning model and there's some sort of bias in some sort of group like this. So there was a pretty famous one a few years ago, maybe 5 or more years ago now. There's a big tech company that had a credit card, and so this is in 2019, actually. I have the quote here. So there's a company with a credit card, and they had a big investigation after gender discrimination complaints. So it was had really high approval rating for men and very low for women, even though, I don't think that's a feature they specifically had in the model, but it was picking up on something there. Somebody said they experienced the schema changes. Shakes fist. I feel you. Yeah, that's always something that I feel like that's probably one of the most common things that people say, and data drift happening. So if you put a model in production, data probably is going to drift at some point. And also there's going to be a change to a library. And if you don't know it, it can really mess up your data. I've had that happen quite a bit too. Or someone turns off a light for like a computer vision model or something like that, which is, I guess, would be like a data quality issue. And then if you've also seen some of the stories with like facial analysis tools, recognition tools, they're also usually pretty biased, often in like race. If, for example, if they're trained in a data set containing, most people with a light skin, and then it doesn't work very well on dark skin. And again, a lot of stuff in credit. So bias and fairness really can happen in any field, but when you're dealing with things like finance and stuff, that's like, I believe, I'm not a lawyer, but I'm pretty sure like, there's actually protective laws around discrimination in this case. So it's actually, really important sometimes for your business to be monitoring for these types of things. Raymond said, everything that is wrong with AI. I did play with text to image. Yeah, I think, I forget if you were in the book club, someone with a similar name is, and I always forget if it was you or not. But someone brought this up too, where they actually did experience that with, I think, generating a headshot. Like you've seen, there's been recent examples with models, making a more professional headshot or something like that, and then completely changing like eye color and skin color and stuff. So how can we monitor for some of these things? A big part of that is looking at data and production. So again, if you were at the last workshop where we did kind of the intro to ML monitoring and we were collecting those telemetry, the AI telemetry that we talked about in that other diagram, we were looking at that over time and kind of see how it was performing. And at the last workshop, we had like a pretty clear shift here. And it was kind of easy to, look at these statistics manually, but also to set up a monitor, say if it drifted a lot, trigger something. But what we can do is we can segment our data, which is what we're going to be doing today. And in this case, this little example, we're going to have like 3 states on the iris data set and see how it's performing. But you could imagine this being, different genders or races or some sort of segment on a group that you want to make sure your model's performing well, continuing to perform well in production, and make sure that those metrics are looking good. So for example, Here, we're just going to look at an accuracy performance, and we're going to go do this hands-on here in a second, but I just want to show as well so you can have those segments and then compare them against each other. In this way, we're looking at accuracy and performance. We could also look at just output. So if you're expecting a pretty even distribution of that data, for example, like men and women should probably have pretty equal approval rates for a credit card, we can be looking at that data in production and then seeing over time, is that what we're seeing, or is there some sort of bias probably going on any class? And you can segment your data on, it could be a class inside your data set, or you could add in other features. So for example, hopefully you don't have, in that case, like probably gender as an actual feature for credit card approvals. And then you could add that in as a separate kind of group to segment your data on. And Raymond said that was awesome. I'm excited to hear about the AI conference. I think you were there, right? I wish I could go. I really wanted to go. It looks fun, or it's still going on today, I think, too, right? So we're going to see an example of this as well. This is a feature we call tracing, where we had those segments on our data, and then we're able to kind of set up a little baseline here and look at all of them across our whole data set, and we could kind of see, in this case, we're comparing accuracy against product classes, and we could see that a few of these we're not doing very well on, and we could say, well, at minimum, we want to have like a 60% prediction rate just in this case, and all of these are well below it. So again, we'll see how to do this with our own data here in a second. So enough slides. Hopefully you probably get the idea of what we're going to be doing today. So I'm going to copy this link again, share it in the chat if you want to follow along. But also these links are in the description. So if you're coming back to this recording later, they're in the description below. And if you want to create the account, if you don't already have one, you can do so here. So you should get a notebook that looks like this. I have a couple open. Let me make sure I get the right one open. All right, so I have my notebook. I'm going to go ahead and hit copy, save, or hit file, save a copy in Drive. It's going to open up my very own copy, so then you can edit all the code, the text, etc. in here. Don't worry about breaking anything. You can always come back to that original link and make another copy if you want. So again, you'll want to have the ylogs account for a little bit later in this book, or in this notebook, because we're going to quickly kind of set up a project there where we can monitor on different segments. And again, if you want to join the Slack channel, ask questions about this later, if you're actually implementing a project, go ahead and do that. And then a quick note on Google Colab. It's essentially Google's way of hosting a Jupyter Notebook, which is a really popular tool to use as a data scientist or ML engineer. It allows us to write code, documentation, and see the outputs kind of all in one place. Again, you'll be able to edit the code in this workshop, so please make that copy, go to File, save a copy in Drive, and you'll be able to do whatever you want with it. So let's go ahead and run our first code cell. You can run the code cells by hitting this play button, or when it's highlighted, you can hit Shift-Enter, which is usually what I do. So you probably won't see me hitting the code button, or the play button. The first code cell takes a few seconds to run because it's actually kind of connecting to an instance here. We actually have a full little Ubuntu instance now. We can even run terminal commands. This is just listing folders in or files in our instance, and we just have one folder called sample data. But it also allows us to do things like pip install libraries. So let's go ahead and pip install ylogs, our open source library for collecting AI telemetry. And just as a quick note too, so Colab comes pre-installed with a whole bunch of the common data science and ML libraries. So it already has scikit-learn installed and TensorFlow, etc. So we're going to be using scikit-learn today, but we don't have to pip install it because it's already there. So we're just going to install ylogs. We actually don't have to restart the runtime. We should be good to go. All right, so if you made this copy, if you were at the workshop 2 weeks ago, we went through this first section. So you're more than welcome to. If you weren't there, you can go open this up later if you want and kind of see a little bit more of an intro to the ML monitoring and setting up a alert for bias, or sorry, an alert for data drift. Today, though, we're going to go through the second section here, which is called ML monitoring for bias, monitoring for bias and fairness with tracing. So these are little arrows. You can open up and collapse those areas. So if you're coming back to this later too and watching the recording, that link should take you here. And if it looks a little bit different, just collapse this first one and open up the second one. So let's go ahead and import our libraries. We're going to be using ylogs, NumPy, Pandas, Datetime, OS. And then we're going to import train test split from scikit-learn. And we're going to load in the iris dataset to kind of quickly train a model. But don't worry, our data is going to get a little bit more interesting than the baseline of an iris dataset. And in case you didn't know, the iris dataset is kind of the hello world of machine learning. So most people have probably seen this quite a bit. So our dataset looks like this, where we have these 4 features: petal length and width, and sepal length and width, which sepal is kind of the under petal of a flower. You can kind of think of it that way. And then there's 3 classes: Setosa, Versicolor, and Virginica. And then let's go ahead and quickly train a machine learning model. So we're just going to set the k nearest neighbors to 5. So it's a KNN model. It's going to be looking at the 5 closest neighbors to the new data point, making a prediction based on that. We'll see the intuition of that just below this code cell. We're going to create our training data, our feature data, and our target variables here. We're just going to do a train test split. So we're just splitting the training data up and saving 30% of that. We're putting aside so we can get this kind of score below and see how our models does on data it hasn't seen before. And then stratify just means that we're going to try to get an even balance of all those classes in our training and test split here. Here's where we're actually training the model. We're fitting to the X train and Y train variables. And then we're making a prediction. We're just getting the model accuracy here. It's 97% on that data that we tested out. So just to recap, if you kind of forgot what a k nearest neighbor model kind of looks like, is here, this dot here represents like a new piece of data coming in. In this case, the k was set to 4, so it's looking at the 4 nearest neighbors and then making a prediction on that. And we can see that here 3 closest ones are Versicolor and 1 is Virginica. So in this case, it's going to make the prediction that this probably belongs to the class Versicolor. If more were yellow, then it would make the prediction that it belonged to Virginica. And so it's good to remember how, kind of have an intuition of how the models work behind the scenes. So when you're troubleshooting, when something goes wrong with it, you can kind of understand why. For example, in the last workshop, we had data that was like, negative numbers or 0, but we didn't have any unit tests going on. So it was still looking at the closest ones, even though they might have been really far away, was still always predicting Setosa. Or if it had really high values, it was always predicting Virginica because we didn't have any threshold set where the maximum could be or minimum could be. So that was why our model was kind of acting weird last time. So just like last time too, we're going to import batches of data. So don't worry too much about all this. This is just a little bit of setup for bringing our data in. This is just some synthetic iris data that, again, spoiler alert, has some sort of underlying bias in it, and we're going to figure out how to troubleshoot that. But it's just important to know that we come away with a list of data frames that contain all those data batches, and then we have a list of targets so that we can look at the ground truth later and see how accurate our model was. And if you look at one of these, it looks like this. This is the top 5. I think there's 150 rows for each of these, but it just looks like this, where very similar to the iris data set, we have all those features, and then we have a state instead, which is new. So this is what we're actually going to segment our data on today, is kind of which state do these flowers grow in, and see if there's some sort of bias between the states. But keep in mind, this could be any feature. So if you actually have a model in production and you want to look at any other group, whether that's something like we've already talked about, like gender and race are very common things that come up with issues in machine learning. But it could be any segment of your data set. So it doesn't have to be an external group like that. It can be some sort of class. They're like a product or really anything you can think of, however you want to group your data by. So let's go ahead and create a profile with ylogs. And to recap, so the way ylogs works is we pass in a data frame or a dictionary, and then we call y.log. We create a profile, and now we're looking at profile view, and we're going to look at it in pandas. And ylogs just creates these profiles that can contain summary statistics of your data set. So there's not really any raw data in here anymore. So we can see that there was 150 counts, so there was 150 rows there. The cardinality was 49, so there's about 49 unique values, at least in this feature. And if we scroll over, we can actually see the really meaningful statistics that we use to track things or detect things like data drift, where we get a distribution of the max value, the mean, the median, the min, and then we have some quantile distributions as well. And there's some other things that can be good to run tests on, like was it a string or are they all fractional? You can write a little unit test for your data to make sure that the data looks as it should. And one cool thing about these being summary statistics is they're super lightweight. They're customizable, so you can write custom user-defined functions to extract any other metrics that you can think of and log them in here. And then they're also extremely secure and privacy-preserving because, again, they don't contain your raw data. So in some industries, this can be more important than others. So like in healthcare and fintech or finance, a lot of people don't want to or they can't pass their raw data outside of their environment. So to actually creating something like this secure little profile can be really cool. And again, there's links to learn more about the basics here. And then we saw last time, if you were here, where we wrote up these profiles and got a visualization similar to this. And then we actually set up a monitor and it was able to detect when something kind of drastically changed in our data stream or our prediction. So I'm going to go ahead and set up YLabs again. We're going to write these profiles to YLabs, but we're going to do it with a segmentation this time. So I'm going to go to my YLabs platform. And again, you can sign up for that account with the link in the description or the chat if you haven't already and you want to follow along. But I'm going to go ahead and hit create a new resource. So I'm going to hit create a new model. I'll just call this bias workshop. You can call it whatever you want. And then model type, I'm going to select classification model. This just kind of changes the UI for you a little bit and allows it to automatically extract some metrics for these specific types of models. So you can see we have one for like classification, regression, large language models, etc. You can always come and change this later as well. So I'm going to hit classification model, and by default, it's going to be looking at the batches by day. I'm going to hit add model. And now I have my new model here, bias workshop. I'm going to copy over my model ID here, which is model 286. Yours, if you just created a new account, is probably going to be something like 2, I think. Go back to my notebook, go to my copy here, and I'm going to paste in my model ID. Make sure there's no extra space or new line character that comes over with it. And then I'm going to go from the same window to this axis token tab, and I'll create a new token here. Again, I'll call it a bias. And then I'm going to hit copy on this token in that little blue box, bring over my API key, and then I'm going to get my org ID, which is also on this page, here or here, and I will copy this in. Again, make sure you have no spaces or new line characters that show up in here. So now I can hit run on the cell, and we set up our environment variables. So now we can actually write our data to YLabs. So let's create a data frame with model predictions here. So I'm going to just kind of loop through those data frames that we saw before that we had stored from those like 7 batches. We're going to basically be simulating that our model was in production for 7 days and be looking at that production data. So I'm making a prediction with our KNN model, and then I'm just appending those predictions to our data frame. And if we look at it, we can see now where our data frame looks something like this. So we have our feature values, our state, which is what we're going to segment our data on, and then we have our predicted output and probability output. So let's go ahead and write our data to YLabs with the segmentation. So you can go ahead and run this, and this is just going to enumerate through all those data frames and then subtract a day for each one. So it's going to kind of write backwards for a week. Again, this is kind of simulating us being in production for a week. And then there's that y.log where we're passing in the data frame, which is extracting those statistics. And then we're also setting a schema type here where we're segmenting on a column, and we're going to segment on that state column. But again, this could be any other type of grouping that you want to do in your data. And then we're setting the timestamp to what we set it up here. So by default, if you just write a profile to YLabs, which is really just a few lines of code, if you're not kind of backfilling like we're doing here, by default, the date time is going to be the date and time that you write it up, but you can overwrite it just like we saw here. So now if I go back to YLabs and go home, I'm going to click into my project here. And this is our kind of summary dashboard. This gets more interesting with the more data that gets uploaded here. I can go look at inputs. And again, if you were here at the other workshop, you've seen this before where we could click into one of these. And now we kind of have a distribution metric for all of our input data. But if you were here last time, it was kind of easy to see, like we could hover over this and look at just say the median and kind of clearly see that on a couple of days, the data definitely shifted and, probably was out of line what our model was trained on. In this case, it's a little bit more tricky. If we look at kind of just the median value, let's say for all these different days, it's actually pretty similar aggregate on every single day. So there's not a clear thing of probably like shifting data that's going on here. So what we can do, because this is on segmentation and bias, let's go ahead and go over to our segments tab here. And then we can click into any of these. So you can see these are the 3 states that were on our data set. We had Florida, Missouri, and Washington. I can click on one of these. It brings me into kind of the same format here where I can look at the data distribution, but now I can change it between all these different states in this case. But again, it could be any group that you segmented your data on. So now I could actually eyeball this and see, right, the median is 4.3 to 5 basically on Washington. Missouri, I can look, it's about the same. Florida, I can look, and Florida is actually quite a bit higher. So the value here is 5 something, almost a whole digit higher, which could be, if our whole model was trained on that 4.3 and had never seen these higher values before, chances are it's going to be making probably not as good predictions. And if we went over to our output tab, we can actually kind of see this in action a little bit. So let's look at just the predicted classes. And if we looked at all data, maybe our we have historical data in this kind of use case, and we could expect that we expect a pretty even distribution of predictions, right? Like maybe Virginia is a little bit higher here, but it looks like a pretty even distribution. And if I looked at Washington, fairly even. Missouri, a little bit more distribution going on here, but kind of like changes that maybe we would expect, and isn't like one is always being predicted. And then if we look at Florida, we can see that definitely all of these, a lot of them are being predicted as Virginica. Like there's a trend going on here. And so far we've only looked at just the input data going into the model and the output coming out of the model, not even the ground truth yet. And we could gain a lot more if we go back and add kind of ground truth value here. We can use some other features in here to compare performance, but already just with that input and output, like I'd mentioned, bare minimum, if you can start monitoring these types of things, you can often kind of find out when something's going on with your model in production. So here we could have a signal that basically, well, Florida seems to have a lot of Virginica. Maybe they're growing more of that there. Maybe they're not, because like in this case it's a farm or something like that, and we know that we're expecting a pretty even distribution of these things throughout like a month. Clearly there's way more Virginica going on here. So I'm going to go back to my notebook. I can run these next code cells here, where this is going to write classification score up, but with that segments. So I'm just going to run through that real fast, and then I'll talk about it. So here, all we did is add that ground truth that we had saved when we imported our data into our data frame here. So now we have this data frame containing all of our data. And then I'm importing log classification metrics. And then we are kind of looping through just like we did with the other data. But now we're logging just these 2 columns, the ground truth and class output, and then segmenting again on that state value. And then looping through, subtracting a day just like we did before, and we're writing that up. So if I go back to ylogs now, go into this performance tab, we have the overall performance. So things like accuracy, recall, FPR, F1 precision, etc. All these are kind of calculated here. And then now you can compare them by, all data, and then, look at how each state is doing versus all of the data. So here we can see Florida, let's say we're choosing accuracy or recall to look at right now. We can see that accuracy is quite a bit lower for Florida than the overall data set. That's not true for Missouri, and that's also not true for Washington. Washington's actually way higher accuracy. So it's really cool. It gives us some indication of, like, again, that Florida probably, has a different distribution of data, and maybe we need to retrain our model with that distribution now. And another really cool way, if you have a lot of features to kind of dig even deeper into this, is this tracing tab here. So you can open up. And then here we have in this dashboard a couple ways of comparing and kind of really digging into your data set a little bit more. I like to think of this as like, if you have a lot of features, especially, this can be really useful. In this case, we just have 3 that we're segmented on. But if you have, I don't know, 10 or something like that, it can be really cool to kind of dig in deeper to your data set here. It's kind of like finding like a needle in a haystack of like what's going on. So here we have a chart showing our accuracy, kind of like we saw before for our overall data set here. And then we can actually see the accuracy per segment. So we have Missouri is 95 plus, Washington is about 95, and then Florida is quite a bit lower, in this case with 79. And we can compare specific profiles. We can change these metrics that we want to kind of look for. So that was accuracy. We can do all those ones that we saw in the other tab here, but it kind of gives us a different view of diving down into our segments. If you look at precision, recall, etc. And then you can also look at the secondary metric, which is kind of this lighter blue box here. So false positive rate, we can see that also the false positive rate for Florida was quite a bit higher than all these other states. And you can compare specific profiles. So here we're looking at all of the profiles kind of aggregated together. And then here we can compare specific ones. So in this profile, actually, Florida's pretty good accuracy. Overall, though, still wasn't. And you could select a different one, kind of see how, like what days actually really affected it probably the most. So a good way, again, kind of tying back maybe to specific days that might have caused the big drop in metrics here. Any questions so far? Does it seem like an interesting feature? And if you were at the last workshop, like we had talked about, we dived a little bit deeper into kind of monitoring overall and detecting data drift. This is kind of the next thing, and a lot of people were asking about it last time to kind of show it about how you can have these segments and drill in to how your data set is performing. And that's actually kind of the majority of what I want to show there for bias and tracing. Again, let me know in the chat if it seems like, that's like a pretty helpful thing and kind of what you were expecting, like when we talked about it last time, if you wanted to see the preview or demo of it in action. Wrapping up, though, so there's way more reading you could do. And if you want to read more about segmentation, again, these links are in that notebook. So if you're coming back and just watching the recording, you can just go to the notebook and grab all of these. We have a lot of resources around setting up things like performance tracing and detecting bias in models. I like this cute dog that shows up too when it says you're leaving Colab. So I'll stick around for a few minutes if anyone has questions. Also, just reiterating, this notebook, it has other parts of kind of this workshop series that we've been doing. So if you were here for the other one, or sorry, you weren't here for the other one, and you want to run the code to kind of detect data drift going on in production with a similar type of model, you can run all this. It'll be kind of similar to what we did, but it breaks it down a little bit more. And then instead of having the data where you need kind of the grouping like we had here, you can actually see it basically in that first visualization tab, and then set up a monitor there in the platform. You can also set up monitors on segments as well. So again, you could go to Monitor Manager. There's some presets here that you can actually select. So if you're looking for like data drift in your data or data quality issues, you can actually go to Segments and set up a monitor from the segment as well. And then so you could be looking just at the Florida data, for example. And if that changed quite a bit or went above or below a threshold, you could trigger some sort of monitor where, again, you could get the alert and notification or trigger something in your MLOps pipeline. There's also the section below the one we just went, which goes more into the open source product. So if you want to use just ylogs in your own local Python environment, you can use it to generate data drift reports, detect data drift, and also set up unit tests on your data as well. So like we had talked about why models might go wrong in the intuition part of the KNN. So if you had a negative number or a really high value, you could basically set up a little unit test on your data there and don't run a prediction if it doesn't meet that threshold of requirement. Awesome. Well, I don't see any questions. I still see people hanging out here. So I'll wait another minute if people do have questions. And otherwise, I'll probably go ahead and wrap up the stream. We were able to actually keep it under an hour today. Usually I go over an hour. I think I'm getting a message on LinkedIn, not in the chat. All right, everyone, I'll wrap up the stream then. And if you have any questions later, one, you can stay connected with me on LinkedIn, or you can join the Slack channel that I posted about, or the link is in the description. And if you want to kind of implement this type of thing, but in your own production system or your own model, and if you have any questions about that, let me know, either on LinkedIn or the Slack, and that'll be a good way to reach me. Otherwise, I'll hopefully talk to some of you all again at some other event, and it was great to have you here. Have a good day, everyone.